very grateful for this opportunity. We are, as you rightly said, going to talk on a case study on Ashaiman and Iture bridges. I've been the project manager for BMU. We had a lot of work we did on concrete and steel bridges. We are responsible for maintenance of bridges across the country. And for this presentation, to give a full light of what the topic is all about, we need to go into the details of the work from where we start up to where we have gotten to in the process of the study that we've mentioned. So the outline of the program is going to be talk about the importance of bridge maintenance, some important bridge news to tell us about the importance of this, an inspection of bridges, types of cracks that we see in beams when you go on inspection, types of maintenance intervention that should, depending on the situation, what type of maintenance intervention we go through. Then common defects in concrete bridges. We also talk on deterioration mechanism, the process that the bridge elements go through before those defects are seen, and also the extending bridge service life, what we do to extend the service life of the bridges. So on that extension of the bridge service life, we take structural strengthening as a case that we have worked on Ashaiman overhead repairs and strengthening, and we attempted doing same on Iture bridge study, but at the course of the presentation, we shall see why Iture bridge could not have received same approach as Ashaiman overhead bridge had. Then at the end of it, we shall have a recommendation for the Ghana Highway Authority on what steps to take. So now on bridge maintenance. Yes, bridges are a critical component of road and transport sector. Without a bridge, no matter how beautiful roads are constructed, if there is no link, when there is an obstruction, there is no way the road will function. So it's a bridge that links the two roads when there is any obstruction. So it is essential to have regular bridge maintenance for more economic and safe use of the road infrastructure. If the bridge are not well maintained, cases which we are going to give example will happen, and the economic life of a community or society will be affected. So the important thing that we come on this, we want to mention some few issues that have happened to bridges across the world, outside the country. We know recently in the news, the Baltimore bridge collapse, which happened in the United States of America on 26th of March 2024. It's a very long span, 2.6 kilometer bridge, which is a steel arch-shaped continuous truss bridge, a very long span bridge where there is a collapse. Collapse when a ship, that is a Dali, called Dali ship, struck one of its piers. Pier is one of the substructure of the bridge, which plays a very vital role. When such substructures are affected, no matter how huge, how big, whatever it is, a single substructure can cause the collapse of an entire bridge. That was what happened when the ship was supposed to pass under the bridge, missed the track and hit one of the piers, the entire collapse. This has caused so much to the United States of America. Baltimore in particular, the Baltimore port has been blocked. Shipping to and fro from the port was become impossible. And for this thing to be blocked, 8,000 jobs were lost by just this accident. And the economic impact on the waterway, on this closure of the waterways causes $50 million per day for the states. That is how serious just one accident on a bridge has caused the country. Another example of a bridge collapse is what we have in Mobi Bridge in Gujarat, India. This also happened about 2 years ago. Bridge which was constructed, which was supposed to have been rehabilitated, it had gone through some repairs. 4 days after reopening of the bridge collapsed. 4 days after reopening of the bridge. Even this one, they have come to do the rehabilitation, to do the repairs on the bridge, but just 4 days, what happened? And what was the consequence of this accident? 140 people died and dozens of others were injured as a result of the collapse. Just one bridge collapsed, instantly 140 people died. And there has been an investigation on this. Report that came by the investigation team talks on 2 things: administrative lapses and technical incompetence, meaning the due process has not been taken to have gotten the right candidate for that job. They were given the job, they are technically incompetent, and they cause a very big flaws in the whole work. So such a thing is because importance has not been given, or some interests have come there where people have lost lives, and the government also has so much to pay for on this particular thing. So one of the reports, technical report that came on this collapse, is that 2 main cables had snapped. The cables, because just like we look at Adome Bridge, we have the cables that we see outside. They are those that are holding the superstructure. So there's like the support is seen up there. When a cable is lost, then it means we have lost some of the supports. So 2 main cables have snapped, and that half of each cable wires might have broken before even the bridge failed. This was some of the technical things that came after this accident. And it's observed that 49 wires of the cable, 22 were corroded, which indicate that those wires may have already broken before the accident. The remaining 27 wires recently broke. This tells us that there has not been proper inventory taken, proper work when they were doing the project preparation. So there are some things that should have been seen, that these things have to be replaced completely, and those things were not properly done because of, as we said, technical incompetence. And additionally, the vertical suspenders that supported the bridge were incorrectly repaired. The suspenders, we have the cables and we have the superstructure deck. The link between the cable and the superstructure deck are the suspenders. And these suspenders, they were supposed to be repaired, but they were not properly repaired. All suspenders were seen to have been welded with the new suspenders. So this will not work. The steel rods which connected the cable with the platform deck, these were 2 things. We're supposed to have 1 single suspender per cable and the deck, but 2 suspenders were welded, which has been a very serious technical flaw in the entire works. So these are the consequences of not taking very serious or paying much attention on bridge maintenance. Now, inspection of bridges is the first stage of the work of bridge engineers. We first have to go and inspect bridges. So when you go for the inspection of bridges, there are things that we consider. You come there first, you check the top of the bridge. You look at all the things that has to do from the approach of the bridge, the furniture of all these things will be looked at. Every single thing will be considered. One important thing in this inspection is that when you are looking at the top, we have to look at one important aspect of the bridge furnitures, which is the drainage. The bridge drainage is very vital. When there is blockage in the drainage, whatever comes from the bridge deck has to be really immediately drained out. If there are blockage in this will give us a problem. So we check on the top. Every aspect will be checked before we go underside of the bridge. We look at the beams and the slab, the piers, the abutments, and the bearings. These are all important things that on the first, that is a routine visual inspection, we go into these and check them. The critical aspect of this inspection for the concrete elements of the bridge is to observe cracks. because cracks are very, very important things we consider when we are inspecting our bridges. So when we go for this in the inspection, after we got the first information for the visual inspection, it will be recorded. It will be marked and recorded. Based on the extent of the deterioration, the engineer may recommend additional testing. Maybe we've gotten information, and that information, we're not informed enough to know the actual remedial action to take. There may be a further test, and this test is what we call a detailed condition survey. It's not all inspection that will call for detailed conditions. Some of the observations are obvious that we don't need further study, but some we need to go further. And this one is what can also have cost on the particular bridge we're talking about, because when they're supposed to do, because that's the detailed condition survey is more of a destructive one. It's a destructive test where parts of the bridge has to be taken off, either by sawing, by cutting, or by taking a core sample. So when the bridge is already in a mess, then such a survey can rather cause a collapse of the bridge. So it's not always attractive to go into that. But when there is a need for that, it has to be taken care of. Now we go on the bridge. An engineer, when he goes for the inspection, I'm giving an example of what we are seeing there. We are seeing a bridge elevation, 2 abutments, and the superstructure. The superstructure, I'm showing the beams, showing some red lines and blue numbers. The red lines indicate cracks that will be seen in the bridge. Position and the direction of the lines have very, very, they are very important. The direction and the location. If you see the red line 1, it is at 45 degrees in the direction, and we see it close to the support, close to the abutment. These are when the bridge, the sharing capacity of the bridge is exceeded by the applied load. If the applied load that comes on the bridge has given a shear value higher than that which the bridge has been designed for, we shall see these cracks in this direction, in this location. And the 1, 2, which is vertical, which are vertical lines perpendicular to the beams, you see them in the mid-span, the middle part of the bridge. And these ones are flexural cracks, meaning cracks that have come due to the sagging or the movement that has developed due to the loading that has been experienced by the bridge. So this one is also, when it's seen, it means there is a load that has come far beyond what has been designed for. And the third one, which starts straight and turns at angle of 45, this is when the failure is due to combine shear and flexural loading exceeding what has been designed for. And the fourth one, which is horizontally going parallel to the bridge, the beam, shows that we have some problem with the reinforcement. When we have reinforcement, corroding to some extent, there is going to be a loss of bond between concrete under the reinforcement, which is the concrete cover. When we lose that, we see these cracks, and that leads to spalling of concrete. So these are 4 major ones that come on beams. And we have some other cracks that we see in compression members, like the pier and the abutments, which, if time allows, we shall go on that. So these are things that when we see them, then we come back to the desk to see what can be done on this. Because when we have such a situation, if it happens, because there are possibilities that the bridge has been designed for a particular load regime, and at the course of time, the loading or the traffic load has, maybe the bridge has been designed, excuse me to use the word, we have HA and HB using British standard of loading. And if, for instance, British standard has allowed this in HB loading between 30 and 45, and maybe we design it with a midway about 30. We used to design, as we came as young engineers, we designed bridges at using 37.5 unit of HB. If now we are to start using 45 units, it means we have increased the loading that has come on the bridge by the virtue of the applied loads. So this something has to be done. That is where structural strengthening will come in, which we shall talk about at the latter part of our presentation. The next will be the types of maintenance intervention. We have done the inspection, we've come and seen the situation on the ground. Now we have to come and plan what maintenance intervention do we take. The bridges, depend on their status, require maintenance interventions such as routine, preventive, repairs, strengthening, and replacement. And the routine is what is very important, that routinely, the bridge engineers visit the site, take the inventory, come and quickly remedy whatever is going wrong with the bridges over there, because this is less expensive. It's more convenient, but when it's neglected, it will lead to very expensive interventions such as strengthening or replacement. If you have a bridge, small things that can be done regularly will keep the bridge to serve for a longer time, like clearing vegetation in channel and around bridge is one of activities that will be done in routine maintenance, cleaning the entire bridge of debris, vegetation, and accumulated soil materials. Because when you have the bridge and you clean the top and there is rain, water will not be collected, and the water is the biggest enemy of bridge. People will be surprised to hear that but bridges are constructed in water. Why should water be the enemy? No, water is the number one enemy of the bridge. So whatever will cause accumulation of water on the deck or around the beams or in some pockets of water is going to cause a very big problem for the bridge. And also clearing the bridge drainage system, as I said earlier, to avoid stagnation of water on bridge deck. This is very important. And replacing the broken drain pipe and ensuring that it extends to 1.5 meter length under the deck. When you have the bridge deck, the bridge at the sides of the carriage, you want to take the cross section of a carriageway or a bridge cross section, the two sides of it where we have a curb, we're supposed to have some drain pipes, some opening, and the drain pipe. And that drain, there should be pipe that goes beyond the surface of the beam to about 1.5, so that water will not be spilling around, water will not be spreading around the beams when it is flowing the distance. So we have consequence of failure to carry out routine activities. You can see from the picture, this is one of the bridges we have in the country. As I approach, wing walls have cracks. We have a road like this. You can see the curb, the road, the walkway, and where the pipe or the opening for drainage is supposed to be, you can see that it's filled with soil, meaning the drainage doesn't function over there. So whatever comes there will be collected, and that will lead to damage to the bridge. We have, when it's not repaired, this is what it leads to. Now we come to bridge repair and maintenance. Because of the time limits, I think some of we have to skip them to go on the main thing, but these ones are to guide us to understand what the main presentation is going to be. But I think with a limited time, these are important for us to know when we are dealing with bridge repair maintenance: lasting protection and durable repair of concrete components, high performance injection systems, structural rehabilitation systems, sealing of deck slabs, joint sealing, waterproofing of concrete. These things, maybe when it comes to costs and assets, we shall go into them. They are very important in our bridge maintenance and repair works. Some of the common defects we see in concrete bridges, in BMU, we see that there are a lot of serious cracks in bridge abutments and wing walls. We see concrete spalling of concrete elements, and also damage from accidents. These are things when the right approach and materials are not applied to these defects, they may lead to a more dangerous or expensive intervention instead of just doing something small, when it's not done the right thing, at the end of the day, we're going to replace entirely or do bridge strengthening, which is more expensive. Deterioration mechanism, these are some of the things that come in our the processes that the bridge go through. They go through these processes and give us those defects. Corrosion is one of them, carbonation, alkali-silica reaction, creep and shrinkage, influence of temperature. These are 5 important mechanisms that bridge go through and have those defects. So creep and shrinkage, things that can, the effect of creep and shrinkage is what I'll mention here. It brings cracking, loss of pre-stress, bond issues, leakage, and durability. When there's creep and shrinkage in concrete, these are the effects that they have on the concrete. Maybe further opportunity, we'll talk about that. Carbonation is a process also that happens in the concrete when the concrete cover is not properly achieved, and when exposure conditions were not considered during construction. Usually, during construction, we have some things that we consider. For every element in the bridge component or structural component, there is exposure that should be anticipated. And that exposure tells the thickness of concrete cover we should have over the reinforcement. If those things are not followed, then we have such problem. Carbonation, this is one of the problems in carbonation. And chemical attack are also things that come as a result of those mechanisms that we mentioned. And also chemical attacks like chloride attack, this is what it gives us. Then alkali-silica reaction is also a very major aspect of bridge that will need an extensive discussion. These are also some of the effects that we have on bridges, and it causes sometimes an explosive failure. Some are gradual, but failure that after it is observed, there's nothing else that can be done apart if it is observed earlier, then restricting or completely making the structure watertight, then that can halt whatever effect it has. So these are some of the effects that you can see when alkali reaction. This is typical that we suspected when on the motorway N1. But this particular picture, we had it earlier, then the bridge really showed very serious, very serious defects, and it was demolished and reconstructed. That's the bridge on the motorway we call, in highways, we call it Mahama Bridge. This was how it used to be when we saw that it has these defects. But this is now a new bridge altogether. And Asimpaso is a case that a bridge has such things, which is still under study because there's a suspected case of alkali-silica reaction on the substructure of the bridge. This is one of the pictures showing Asimpaso. Now, the exposure classes is what I talk about, and this is just the literature on that. Then, extending bridge life is very important. Extending the bridge life. The observation on the concrete bridges within our road network is that many have lost their load-bearing strength due to deformation, corrosion, or damage to the original reinforcement steel. Others have been exposed to load regime higher than what they have been designed for, as I said earlier. So some of the bridges we're having, the problems they're having is because of load regime has been changed. They have now been receiving higher load than they have been designed for. Others also are due to impact that have come, vehicular impact on bridge members, and those ones have reduced the load-bearing capacity. So on the structural strengthening, we have the traditional method which we use on the Iture Bridge when we saw the condition of the bridge. Iture Bridge has been a bridge that has really, is in the central region, a typical that requires strengthening and protection against aggressive movement. It is along the national route N1, within the haulage route. This is a very important word. Haulage route are the routes that always receive the heaviest load, where abnormal loads are often applied. And this bridge is within that route, that corridor. To increase its load carrying capacity, steel fabricated props have been provided to all the 3 spans. We increase the PS by giving them more fabricated props to reduce their spans. And at July 2022, upon inspection of the bridge, the following observations were made, which are very important. One span has the entire prop washed away, meaning one span is free. The support that has been done to strengthen it is no more there. And the remaining 2 spans have either loose, they are either loose or they have no contact with props. The props are there. The bearing that we put between the prop and the underside or the surface of the slab, those, because of settlement of the props, the material under the props are being washed out because of the tide that comes from the sea up and down. It washes that and settles, so now there's a loose contact. And cracks are widened. Some of the prop members are scattered in the water. Just as you can see, this Iture bridge, we can see if you see the last end, the props are not there at all. But the middle span and the first span have still some props there. We have here some of the spans showing this is a serious thing that shows underside of the bridge. We can see attack. The very possible chloride attack from the sea is eating into the bridge and cracks are widening. This is a bridge that we always play on the N1 at Iture Central Region near Elmina. This was the condition in 2022. Only God knows what the condition will be today. So Iture, these are some of the washout. Yes. So now we have the case, what we're able to use. You know, the alternative or the more advanced way of structural strengthening is using carbon fiber reinforcement polymer, that is CFRP. This is a composite material used in repairing as well as strengthening reinforced concrete structure. If you could see what we did on the Iture bridge, we are supposed to bring what? Props, fabricate props, put them within the span, 2 more props in every span to reduce, meaning every single span, we made it triple span. If it's 30 meters, we reduce it to 10, 10, 10. That was what we did on Iture to hold the bridge. But the more, engineered and more advanced one is to use the carbon fiber reinforcement polymer. And compared to this alternative traditional strengthening solution of concrete jacketing that we did, the main advantage of CFRP strips are they have very high tensile strength, high stiffness, relatively high deformation capacity, their lightness is there, and the reduction of labor costs. They are corrosive, they are non-corrodability. These are some advantage that we have on this system. So we had a typical strengthening carried out BMU 4 years ago. 3 years ago, we had 2020. We had work on the Ashaiman overhead, a typical structural strengthening carried out by BMU using carbon fiber reinforcement polymer was on this bridge. And when it had a very severe vehicular impact, the entire work was completed within 24 days, the entire work. Even these 24 days, only 15 days on site where we affected the traffic, only 15 days that we affected the traffic on the motorway, because all the plans for this work, how we have little alternatives to link between Accra and Tema, complete closure of motorway was no way for us. So, and we didn't have any opportunity of diversion around the bridge. So the only thing that we should do is to manage the traffic. So 24 days, 15 days was used on site, 9 days off site. And this 9 days was what we used for public education, this in off-site fabrication, and all these things were done. So 24 days doesn't mean 24 days holding on the traffic of the or distracting traffic. And the activities we carried on in this particular project: propping the damaged beam, breaking and removal of concrete from damaged section, drilling and installation of shear connectors, applying corrosion protection, erection and fixing of formworks, casting of concrete, sandblasting the surface of repaired beam, and applying adhesive and installation of carbon fiber, and applying the finish coat. These were the things that were, so this was Ashaiman when there was such a serious impact on the bridge. This was the impact. We can see a very huge beam of an I section. The web has been affected. The bottom flange has been seriously affected, and also close to the mid-span, we can see the pre-stress tendon that's a use, or the post-tension tendon, have been exposed. All the reinforcement have been affected. This is a very critical aspect of the bridge that have been exposed. Leaving them for a long time will lead to corrosion, because Ashaiman is not far from the sea, will lead to corrosion, and also the vehicular traffic still being plied on. So it was something that needed a quick intervention, and the solution was gotten through the use of this. So we have in the process chiseling to expose the rebar. So in this process, the rebar has been you could see that part of the damage and still left in the web have been clearly removed through chiseling. And for us to avoid further impact on the bridge, it is drilling, cutting, and a few just to avoid vibration around it. So this process is what we took in getting into the solution to that. So we have this is still in the process where we cleared, and now we're fixing the prop to support the beam formwork, because the formwork of the beam has to be well. So we have this, this is for chiseling and exposing the bars, and also the tendon. Then the next is some of the beams which receive minor injuries. For them, we apply structural mortar after applying bonding elements to link them, because they all need to be protected. All the areas that have some injury due to the impact, we use structural mortar on them. And this is fixing of the formworks, a very heavy, because we have to fabricate the formwork to take the shape of the beam, having the web and the flange. And also, one important thing is about the casting of the concrete. The concrete is supposed to be cast from the side, and it has to be self-compacting. It has to have high pumpability, because all these things were considered. So even the recipe for the concrete, we consider all these things: fast curing, high pumpability, and also should be self-compacting. So this is a formwork we did, and formwork fix. Then the concrete cast. After the concrete cast, the next is to apply the fiber, carbon fiber polymer. That is what we are putting underline after we did the sandblasting and other activities, which time will not allow. So at the end, this is what we have completed, what we've gotten to complete the repairs of the bridge. And this is the team that did the work, and engineer Amuzu Enam has been the site man on the project, and the team that worked with him is there with his boss, the Sheikh Aminu Issaka Abubakar. And we have the recommendation that we have for GHA on this particular presentation is that there are three aspects of things that should be considered. One, about design of a concrete structure. It's important that issues to do with soil investigation should bring everything about groundwater table, chemical composition of the groundwater, chemical composition of water body around the structure, so that contractor will be responsible for using the right additives, the right admixture for his work, and also waterproofing that should be used. Proper ones should be used, because all the problems, if from the construction, design and construction, we use the right thing, we shall have less to worry about when it's come to the maintenance. And maintenance of the concrete structures, also bridge maintenance units should be given training to attain certified applicator agent, especially for injection, grouting, and carbon fiber polymer mixing. All necessary equipment and tools should be procured for BMU to enable it to carry out these activities whenever the need arises. And using carbon fiber bridges along the haulage routes, we request that bridges along the haulage routes where we should, if you can use, where abnormal loadings are applied, we should use the carbon fiber to strengthen them, and Iture bridge should be given a load restriction. This is request. Iture bridge should be given a load restriction whilst BME mobilizes to reinstate the washed-out props whilst awaiting the replacement of the entire bridge. Thank you.